Hey guys! In this video, I'm going to be going over decomposing a higher order differential equation into a system of first order differential equations so that it's easier to solve a higher order differential equation problem. So let's go ahead and get started. I have this given differential equation here, and m in this differential equation is just some arbitrary constant. You can just think of it as some random number that stays in the differential equation. So the first thing I'm going to want to do is isolate the highest order derivative to the left-hand side. So I'm going to take and rewrite my differential equation. So 2 times the third order derivative plus the second order derivative minus 3m times the first order derivative plus mt equals 0. So let's see, we have a third order, a second order, and a first order derivative. So the third order is our highest order derivative. So we're going to want to isolate him to the left-hand side of the equation. So I'm going to move everything else over to the right-hand side. So that will give me 2 times the third order derivative equals negative second order plus 3m times the first order minus mt. And then I'm going to take and divide everything by 2, which is the same thing as multiplying both sides by 1/2. And that will give me the third order derivative is equal to negative 1/2 times the second order plus 3m over 2 times the first order minus 1/2 mt. So the second step is to set all the other higher order derivatives equal to dummy variables. So before I do that real quick, I'm going to go ahead and identify my independent and my dependent variable in this differential equation, because that will make it a little bit easier for when we put the system of first order differential equations into a matrix. So the independent variable, you can think of this as an independent woman. It doesn't need anyone else. It doesn't care what goes on in the rest of the equation. This independent variable is going to have its set values, and that's that. Usually in engineering, I see time or distance as the independent variable. Obviously, those aren't the only independent variables you can have, but I think those are the most common that I've seen. So the independent variable is the variable that's on the bottom of the derivative, because it's the variable that this equation is with respect to. So in this case, it's t. And then our dependent variable is the variable that depends on the woman. It depends on the independent variable to determine its value. So in this equation, the dependent variable is y, and that's on the top of our derivative sign. Okay, so now we can move on to step 2. So basically what we want to end up with eventually for step 2 is our highest order derivative. Let's do dark blue. So our third order equal to some equation in terms of dummy variables. Basically, the dummy variables are going to replace all of the derivatives on the right-hand side of the equation, or the right-hand side of this equation right here. So let's go ahead and start with the first order derivative, so dy over dt. So I'm going to say dy dt, let's set it equal to any variable or shape or whatever you want to pick. Let's say v. So if we take the derivative of v with respect to t, which is the independent variable in this differential equation, that's the same thing as the second order derivative of y with respect to t. So now let's go back to our equation, and we need to set a dummy variable equal to this second order derivative. So I'm going to say the second order derivative is equal to w. So then we could say that the derivative of w with respect to t is the same thing as the third order derivative of y with respect to t. And if you notice, that is our highest order derivative in this equation right here. So then we can say that this is equal to our equation, but instead of the derivatives, we're going to substitute in our dummy variable. Just bear with me here. I'm trying to make sure I color code everything. Okay. So now we can go ahead and move on to the third step, which is to create a matrix. So when we create our matrix, we are always going to have the derivative with respect to the independent variable. And then we're going to have a left-hand side matrix and a right-hand side matrix. The left-hand side matrix contains the dependent variable and all the dummy variables that we selected. So the dependent variable and our dummy variables. And then the right-hand side matrix has the derivatives and the final equation in terms of the dummy variables. So have derivatives and our final equation. So let's go ahead and start with our dependent variable. So we have y. Now the derivative of y is v, right? We have this equation right here. So I'm going to put v right here. And then I'm just going to take and bring v down to the second spot in my left-hand side matrix. And then I'm going to do the same thing again. So I'm going to take the derivative of v. The derivative of v is w, because w equals the second derivative of y, and the second derivative of y equals the derivative of v. So I'm going to put w right here. And then I'm going to bring w down to the next spot in my left-hand side matrix. And then I'm going to take the derivative of w. And the derivative of w is our equation in terms of dummy variable. So I'm going to take and put that equation in this third spot on my right-hand side matrix. So I have negative 1/2 W plus 3m over 2b minus 1/2 mt. And so this right here is my matrix of the decomposed differential equation. And so that's it. I hope this video helped you guys better understand how to decompose a higher order differential equation into a system of first order differential equations.